Welcome to a new Unreal Engine 5 step-by-step tutorial. In Paragon Character Series number 5, we'll explore how to make a Paragon character crouch. I'm currently working on Dungeon Forge, Legacy, an RPG, and I'm sharing my game dev tips with you along the way. If you're not sure how to retarget Mixamo Animations for a Paragon character, I highly recommend checking out my previous tutorial, Paragon Character Series number 4, link in the description. If you're ready to level up your game dev skills, hit that subscribe button and give this video a thumbs up to support the channel. By the end of this tutorial, you'll know how to transition your character from standing to crouching and back, as well as how to make the character move while crouched. Head over to Mixamo.com, you can create a free account if you don't already have one. Click on Characters, type YBot in the search bar, and select YBot. Then, click on Animations and pick the animations I'll show you in the video. Filter the results by searching for Crouch. First, grab the animation called Crouch Idle, it's a magician with a raised hand. Click Download, select FBX format and choose with skin. Next, download the animation called Crouch Forward, also from the magician. Important note for this animation, make sure to check In Place. The character needs to walk in place without moving forward. All these animations must be in FBX format and with skin. Then, download the next two animations from the magician, Crouch to Standing Idle and Standing Idle to Crouch. You should now have 4 Mixamo animations that need to be retargeted to work with your Paragon character. My previous tutorial, Paragon Character Series number 4, explains how to do this, check the link in the description. Let's make sure you have all the animations ready. In your project, under Characters, Mixamo, Animations, you should see the 4 crouch animations you just downloaded. In your Paragon Characters animation folder, you should have the 4 retarget animations adapted for your Paragon skeleton. Let's start by modifying the character's blueprint. Add a Keyboard Event C node. Drag and drop the character movement component into the event graph. From the character movement, add the is falling node. Then add a not node, followed by a branch node. This ensures the character can only crouch when it's not in the air. Add a new variable by clicking the plus sign, name it isCrouched, with a question mark at the end to distinguish it from the existing isCrouched variable in Unreal Engine. Drag and drop this variable into the graph while holding Ctrl to automatically create a get node for the variable. Add a branch node. Drag and drop the isCrouched variable directly onto the true output of the branch. This will create the link and add a set node automatically. Repeat the process for the false output. If isCrouched is true, we set it to false. If isCrouched is false, we set it to true. Drag and drop the character movement again, and add the set max walk speed node. Duplicate the whole setup using Ctrl+D, or copy with Ctrl+C and paste with Ctrl+V. This allows us to adjust the movement speed depending on whether the character is crouching or not. Drag and drop the capsule component, then add the set capsule half height node. Duplicate the setup. This adjusts the capsule height to handle collisions properly. Drag and drop the mesh. Then add the Set Relative Location node. Duplicate the setup. This aligns the character's mesh with the capsule. Now, let's fill in the values. Based on my tests, the movement speed for the crouch forward animation should be 200. Let's find the movement speed for when the character is running. Select the character movement, type walk speed in the filter field. My Paragon character's value is 600. Let's apply this value to the set node. Next, check the capsule half height by selecting the capsule component and filtering for half height. For my character, the value is 95. Based on my tests, the value while crouching is 70. This can vary depending on the animation, as the character might crouch more or less, affecting its height. Now, let's check the Z location value by selecting the mesh component. It's -97 for my character. I'll right-click and select Split Struct Pin to show you the X, Y, and Z values separately, but you can also just enter -97 directly in the rightmost field. For the mesh value in the crouched position, you should use a value close to that of the capsule, but in negative, approximately -70. Since there is a 2-unit offset between 95, the capsule height when standing, and -97, the relative Y position of the mesh when standing, I apply this offset and adjust the value to -72 for the crouched position. Select all the nodes we just added and press C to create a comment box. I'll name it Crouch. Find the comment box labeled Jump in the event graph, select it, and move it near the new Crouch nodes we just created. Add the isCrouched variable, connect it to a Not node, then to a Branch node. Duplicate the setup with Ctrl+D and connect it as shown in the video. This prevents the character from jumping while crouched. This is a gameplay choice, and it's the one I've implemented in my game, Dungeon Forge Legacy, currently in development. That's it for the character blueprint. Let's move on to the Anim blueprint. If you're enjoying this tutorial so far, don't forget to like, comment, and subscribe to catch the next episodes of Paragon Characters. Let's open the Anim blueprint and select the event graph. The goal of this edition is to retrieve the value of isCrouched from the character blueprint. From the try-get-pawn-owner node, add a cast to node named after your Paragon character. From this node, get isCrouched, make sure to select the variable that ends with a question mark. Select Promote to Variable to create the same variable in the Anim blueprint. Select the added nodes, and press the C key to add the comment, Set isCrouched. Don't forget to connect the added nodes to the existing ones. Compile, and save. Now let's move to the AnimGraph. Let's organize the existing nodes to make space in the comment area, locomotion and AMP, Anim offset. Move the state machine node named locomotion, and delete the link by holding Alt and pressing Delete. From this locomotion state machine, right-click to add the new Save Cached Pose node. Name it Cached Locomotion. Then right-click to add a state machine node, name it Crouch State. From this state machine, right-click to add the new Save Cached Pose node. Name it Cached Crouch State. Let's look at what's inside locomotion by double-clicking it. locomotion handles the idle/jog animation, and manages jump animations. Go back by clicking the return icon, or directly on the breadcrumb. We'll do something similar to manage crouch animations in crouch state. Double-click on Crouch State, right-click Add State, add a link from Entry to State. Right-click, Add State, and name it Crouches. Add a link from State to Crouches. Double-click the condition above this link to open it. Drag and drop the isCrouched variable we previously created in the event graph. Connect it to the result node. Exit the condition with the return arrow. Add a link from Crouches to State. Double-click the condition of this link. Drag and drop the isCrouched variable, add a not node, and connect all nodes to the result. Double-click on Crouches. Add a State Machine node, name it Crouches, and connect it to the Output node. Open Crouches. We'll now add the crouch animations that have been retargeted for the Paragon character. Add a state named to Crouch, and open it. In the Asset Browser tab, filter the animations with RTG. If you don't see the Asset Browser tab, go to Unreal Engine's Window menu, and click Asset Browser to make it appear. Drag the Standing Idle to Crouch animation, and connect it to the Output node. Add another state, named Crouch_Walk, and open it. In the same way, drag the Crouch Walk Forward animation, and connect it. Add another state, named Crouch_Idle, and open it. In the same way, drag the Crouch Idle animation, and connect it. Let's repeat the steps for the last animation. Add another state, named From Crouch, and open it. In the same way, drag the Crouch to Standing Idle animation, and connect it. There you go, all crouch animations have been added to the AnimGraph. Now let's manage the transitions between these animations. Connect Entry to Crouch, and to Crouch_Walk. Open the condition, drag the Speed variable, add a greater than node set to 50, and connect everything. This means we switch from the crouching animation to the walking animation only if the speed is greater than 50. Connect to Crouch_Idle, and open the condition, which will be speed less than or equal to 50. Connect Crouch_Walk to Crouch_Idle, and open the condition, which will be the same, speed less than or equal to 50. Connect Crouch_Idle to Crouch_Walk, and open the condition, which will be speed greater than 50. Connect Crouch_Walk to From Crouch, open the condition, and add the isCrouched variable, the not node, and connect the nodes. This means we exit the crouched walking state if the isCrouched variable is set to false. Connect Crouch_Idle to From Crouch, and set the same condition. Compile, and save. Go back to the top level of the AnimGraph using the return icon, or by clicking on the breadcrumb. Now, let's do a first test to check if the crouch works. Open Crouch State, then State. Right-click to add Use Cached Pose ground_loco, and connect it to the output. I've checked several Paragon characters, and there's always a ground_loco. This is just for the test, we'll remove it right after. Back at the top level of the AnimGraph, right-click to add the Use Cached Pose Crouch State node to the Base Pose input of the blend space. If your character doesn't have a blend space, connect it to the LocoPose node, or any following node. You'll also need to remove it after the test. Compile, and save. Let's launch the level. The character moves, it's not possible to jump for now, but it can crouch. Oh, and there's a problem, in the crouched position, the character seems to slide after a few seconds. Let's fix this by going back to the AnimGraph, then into Crouch State, then Crouches, again into Crouches, then into Crouch_walk, and finally select the Crouch Walk Forward animation. In the Details tab, check the box labeled Loop Animation. Compile, and save. Let's test again, and there we go, the crouched position works. We'll now finish the AnimGraph so the character can still jump. While crouched, we'll only keep the Mixamo animation for the lower body, because you notice that the right hand and the sword end up in the air when crouched. If you find this tutorial helpful, don't forget to subscribe and like so you don't miss the next one. Back in the Anim blueprint, let's remove the two nodes we added for the test. Go back to the state, and remove Use Cached Pose Ground_Loco. At the top level of the AnimGraph, remove Use Cached Pose Cached Crouch State. Compile, and save. Find, and select the Layered Blend Per Bone node already present in the AnimGraph, and copy it. Paste it and connect it to the Base Pose input of the blend space. This node, as already configured in the AnimGraph, allows for two inputs, Base Pose for the lower body, and Blend Poses for the upper body. Add a Blend Poses by Bool node, connect it to the Base Pose of the Layered Blend Per Bone node. Add a second Blend Poses by Bool node, connect it to the Blend Poses of the Layered Blend Per Bone node. Add the Use Cached Pose Cached Crouch State node, connect it to the True Pose input of the first Blend Poses by Bool. Drag the IsCrouched variable, connect it to the active value of the first Blend Poses by Bool. Add the Use Cached Pose Cached Locomotion node, connect it to the True Pose input of the first Blend Poses by Bool. Drag the IsCrouched variable, connect it to the active value of the second Blend Poses by Bool. In the Asset Browser tab, search for the idle animation that matches your Paragon character, not the crouch idle animation, but the standing one. Drag it and connect it to the True Pose input of the second Blend Poses by Bool. Add the Use Cached Pose Cached Locomotion node, connect it to the True Pose input of the second Blend Poses by Bool. Compile, and save. A quick explanation of what we just did. And the second Blend Poses by Bool handles the upper body. The first Blend Poses by Bool handles the lower body. The Blend Poses by Bool nodes allow sending different animations depending on whether the character is crouched or not. If the character is crouched, the True Pose inputs are used. We then send Cached Crouch State for the lower body, and the Paragon Character's idle animation for the upper body. If the character is standing, the False Pose inputs are used. We then send Cached Locomotion for both the lower and upper body. Let's test. The character can move, crouch, walk while crouched, stand up, jump. We notice that the position change is too abrupt. Let's adjust this in the AnimGraph. Set the value 0.3 in the True Blend Time of the first Blend Poses by Bool node. Do the same for the False Blend Time. Let's test again, and we see that the character crouches and stands up more slowly. We can also adjust the blend weight to slightly take into account the Mixamo upper body animation when the character is crouched. Let's try a value of 0.5 in the blend weight of the Layered Blend Per Bone node that we copied. This causes an issue with the fingers starting to lift, like in the Mixamo animation. Let's adjust the value to 0.8 and test. There we go, the character has slightly bent arms, and its posture is less rigid. Let's test sword attacks while crouched. We notice that the character stands up to perform them. To avoid this, we just need to make a small tweak in the AnimGraph. Find and select the Blend Poses by Bool node that was already present. Add an OR node before the active value input, connect its first input to the existing AND node, connect its second input to the isCrouched variable. Compile, save, and test. And there you go, sword attacks work perfectly, both standing and crouched. The character crouches and stands up smoothly. It's possible to move while crouched. It's still possible to jump. Join our growing community by subscribing, give a thumbs up to boost the channel's visibility, and allow me to create more content for you. This tutorial is longer than usual. What did you think? Do you prefer short tutorials or more detailed ones like this? Let me know in the comments. I hope this tutorial helped you better understand how the AnimGraph works. Thanks to everyone for watching, and I'll see you soon in the next tutorial, and a video about AI in game development.